audio space, which is actually a really awesome workspace, finally opened up, since all the things that have been going on with COVID. So I'm just going to do the other two read-alongs for those topics. So let's do that. Let's go back. So we just talked about a data lake. Let's talk about predictive analytics, because I talked about this, and I do feel like there are some people who don't know what it is. Okay, so predictive analytics, what is it? Predictive analytics is the use of historical data, statistical algorithms, predictive modeling, and big data machine learning techniques to help organizations predict future outcomes more accurately, plan for unknown events, and discover opportunities in future activities. As a branch of data science for business, the growth of predictive and augmented analytics coincides with that of big data systems, where larger, broader pools of data enable increasing data mining activities to provide predictive insights. Advancements in big data machine learning have also expanded predictive analytics capabilities. Learn how Google Cloud data analytics, machine learning, and artificial intelligence solutions can help your business run smoother and faster with predictive analytics. So predictive analytics defined. Predictive analytics includes a variety of statistical techniques that analyze current and historical facts to make predictions about the future. With the help of sophisticated tools, as well as big data machine learning and AI models, organizations can use historic and current data reliability forecast trends and behaviors seconds, days, or years into the future with a great deal of precision. Experienced data scientists use predictive models to identify correlations between different elements in selected data sets. Once data collection is complete, a statistical model is formulated, trained, and modified to generate accurate predictions. What is predictive analytics used for? Predictive analytics can be used to streamline operations, boost revenue, and mitigate risk for almost any business or industry, including banking, retail, utilities, public sector, healthcare, and manufacturing. Sometimes augmented analytics are used, which uses big data machine learning. Here are some more use case examples, including data lake analytics. Fraud detection, operations improvement, customer segmentation, conversion and purchase prediction, risk reduction, and predictive maintenance. Fraud detection. Predictive analytics examines all actions on a company's network in real time to pinpoint abnormalities that indicate fraud and other vulnerabilities. Conversion and purchase prediction. Companies can take actions like retargeting online ads to visitors with data that predicts a greater likelihood of conversion and purchase intent. Operations improvement. Companies use predictive analytics models to forecast inventory, manage resources, and operate more efficiently. Risk reduction. Credit scores, insurance claims, and debt collections all use predictive analytics to assess and determine the likelihood of future defaults. Customer segmentation. By dividing a customer base into specific groups, marketers can use predictive analytics to make forward-looking decisions to tailor content to unique audiences. Predictive maintenance. Organizations use data to predict when routine equipment maintenance will be required and can then schedule it before a problem or malfunction arises. Related products and services. Google Cloud AI and machine learning products and services provide the foundation for predictive analytics. Available tools and models enable organizations to use data insights to go beyond knowing what happened in the past and toward offering a best assessment of what could happen in the future. For experts, the Vertex AI lets you build complex models more quickly for a lower cost. For novices, AI building blocks lets you add AI to your services. So they have, I'm going to talk about AutoML for a second. So they have quite a lot of examples of how people are using AutoML. But basically what it is, it allows you to train high quality custom machine learning models with minimal effort and machine learning expertise. So AutoML enables developers with limited machine learning expertise to train high quality models specific to their business needs. Build your own custom machine learning models in minutes. If we look at the documentation here, they've got something called a beginner's guide. So here's an intro. So in the index on this page, they've got an introduction. Why is Vertex AI the right tool for this problem? How does Vertex AI work? The workflow, data preparation, training the model, evaluate testing, and deploying your model. An introduction. This beginner's guide is an introduction to AutoML. To understand the key differences between AutoML and custom training, see choosing a training method. So imagine you're a coach for the soccer team, you're in the marketing department for a digital retailer, you're working on an architectural project that is identifying types of buildings. Your business has a contact form on its website. The work of manually curating videos, images, text, and tables is tedious and time consuming. Wouldn't it be easier to teach a computer to automatically identify and flag the content? So there's an example here. You work with an architectural preservation board that's attempting to identify neighborhoods that have a consistent architectural style in your city. You have hundreds of thousands of snapshots of homes to sift through, but it's a tedious and error prone when trying to categorize all these images by hand. An intern labeled a few hundred of them a few months ago and nobody has touched them since. It'd be so useful if you could just teach your computer to do this for you. So there's 4 images, a house, or there's 4 types of buildings, I guess. So we've got like a ranch, a Victorian, a modern, and a Tudor home. So this guide walks you through how Vertex AI works for AutoML datasets and models and illustrates the kinds of problems it's designed to solve for you. So they've got something known as like tabular datasets too. Let's just walk through this example. So you work in the marketing department for a digital retailer. You and your team are creating a personalized email program based on customer personas. You've created the personas and the marketing email is ready to go. Now you need to create a system that buckets customers into each persona based on retail preferences and spending behavior, even when they're new customers. To maximize customer engagement, you want to predict their spending habits so you can optimize when to send them emails. So they've got some types of categories: a browser, someone fashion forward, a last minute shopper, and a discount lover. Because you're a digital retailer, you have data on your customers and the purchases they've made. But what about new customers? Traditional approaches can calculate these values for existing customers with long purchase histories, but don't do well with customers with little historical data. If you could create a system to predict these values and increase the speed at which you deliver personalized marketing programs to all your customers, fortunately, machine learning and Vertex AI is well positioned to solve these problems. This guide walks you through how Vertex AI works for AutoML datasets and models and illustrates the kinds of problems Vertex AI is designed to solve. So there's a note about fairness. Google is committed to making progress in the following responsible AI practices. To this end, our ML products, including AutoML, are designed around core principles such as fairness and human-centered machine learning. For more information about best practices for mitigating bias when building your own ML system, see the Inclusive ML Guide, AutoML. So why is Vertex AI the right tool for this problem? Classical programming requires a program to specify step-by-step instructions for a computer to follow, but consider the use case of identifying specific actions in soccer games. There's so much variation in color, angle, resolution, and lighting that it would require coding far too many rules to tell a machine how to make the correct decision. That's a good point. It's hard to imagine where you'd even begin. Yeah. Or where customer comments, which use a broad range of varied vocabulary and structure, are too diverse to be captured by a simple set of rules. If you tried to build manual filters, you'd quickly find that you weren't able to categorize the vast majority of your customer comments. You need a system that can generalize to a wide variety of comments. In a scenario where a sequence of specific rules is bound to expand exponentially, you need a system that can learn from examples. Fortunately, machine learning is in a position to solve these problems. How does Vertex AI work? Vertex AI involves supervised learning tasks to achieve a desired outcome. The specifics of the algorithm and training methods change based on the data type and use case. There are many different subcategories of machine learning, all of which solve different problems and work within different constraints. So you train, now we're going back to our tabular example. You train a machine learning model with example data, and Vertex AI uses tabular or structured data to train a machine learning model to make predictions on new data. One column from your data set called the target is what your model will learn to predict. Some number of the other data columns are inputs called features that the model will learn patterns from. You can use the same input features to build multiple kinds of models just by changing the target column and training options. From the email marketing example, this means you could build models with the same input features but with different target predictions. One model could predict a customer's persona, a categorical target. Another model could predict their monthly spending, a numerical target. And another could forecast daily demand of your product for the next 3 months, a series of numerical targets. So then we've got the Vertex AI Workflow. Vertex AI uses a standard machine learning workflow. Gather your data, determine the data you need for training and testing your model based on the outcome you want to achieve. Prepare your data, make sure your data is properly formatted and labeled. Train a set of parameters to build your model and evaluate, review model metrics. Deploy and predict, make your model available to use. But before you start gathering your data, you need to think about the problem you're trying to solve. This will inform your data requirements. Data preparation. Assess your use case. Start with your problem. What is the outcome you want to achieve? So in this in our example of tabular data, what kind of data is the target column? How much data do you have access to? Depending on your answers, Vertex AI creates a model to solve your use case. A binary classification model predicts a binary outcome, one of two classes. Use this for yes or no questions. A multi-class classification model predicts one class from 3 or more discrete classes. Use this to categorize things. A forecasting model predicts a sequence of values use. For example, as a retailer, you might want to forecast the daily demand of your products for the next 3 months. And the regression model predicts a continuous value. For the retail example, you want to build a regression model if you want to predict how much a consumer will spend next month. And then we have gather your data, prepare your data, training the model, evaluating the model, and predicting outcomes. So I feel like it might actually just make more sense to make another video that, this is a pretty detailed example here. So I'm not going to continue to okay, this is really cool. So in the developers page as well, you can save pages, and you can go back to your saved pages. This is very cool. I didn't know that you could do that. That is useful because we are going to come back to that. And all of this is connected to your Gmail account. We're going to go back though because we're still on those topics. Let's go back to those topics. So we just read about predictive analytics. Okay, that's the end of this video.